Greetings and welcome, friends. We are on page 128, last night's quest, big ideas, section 3.1. We're talking about parallel and perpendicular lines. It's going to be good. It says, think of each segment in the diagram as part of a line. Guys, I'm getting the points already. Like, if this was on a test, think of how much partial credit I could give you just for completing the thinking part right now. It'd be hard for me to measure, though, but I would assume that you spent the time thinking about these line segments as being part of a line. See, all the angles are right angles. It's all right with me, Lauren. It's all right with me. All these angles are right. Man, if these angles are wrong, I don't want to be right. Right? No? I don't know. Which lines or planes contain point B appear to fit the description below? So here's my point B, bravo. And let's see, lines parallel to CD, there's CD. So it looks like just line BA or AB would be the only case that would make that true. Let's see, lines perpendicular to CD. It would, but it doesn't contain point B, so you might have missed that one piece. But yeah, I would agree. I would agree. All right. So, and then let's see, perpendicular to CD, but through point B would be right there. So it looks like BC, the line. BC, the line. Good stuff. All right, let's keep cracking. Exercises 7 through 10, use the diagram. Name a pair of parallel lines. A para. Looks like, yeah, I skipped around. That's all. Don't worry. Looks like MK, the line, is parallel to LS. I don't know if you guys agree. Right. MK parallel to LS. Now, it appears as though PR could be, but it's not labeled, so I cannot conclude that. And let's see, name a pair of perpendicular lines. That looks like the only ones that are labeled would be NP is perpendicular, that's the upside down T, to PQ. Right. You guys are masters at this now, right? And you got your notation down. You guys are good. I can't wait. Today's lesson's going to be awesome. Okay, using structure, classify the angle pair as corresponding alternate interior, alternate exterior, consecutive interior angles. Let's see, angles 5 and 11. Bless you. Oh, sorry, 5 and 1. I was going to say there's not an immediate relationship that I could relate between those two things. 5 and 1 are corresponding. Let's see, I just on ding angles, right? And the reason that is true is because those are in the same relative direction from their respective intersection, right? So for this little intersection here, the 5 is in kind of like the northwest territory, and for this intersection here, the 1 is in the northwest territory. That's the way I think about corresponding angles. Good. Let's see, last problems. Man, this is nice. Last night's homework, I hope, was easy. I would hope. I'm hoping. Let's see. Copy and complete the statement. List all possible correct answers. Angle BCG. BCG. Let's see. Is this guy right here? Ooh, this one's going to be tricky. And blank are corresponding angles. Up here, from angle J's perspective, which angle would be corresponding? Looks like HJG. All right. So angle HJG. And how about from angle F's perspective? Which of its angles would be corresponding to this angle right here? I think this one, right? From this intersection, it's kind of like this direction, as best we can. So yeah, looks like CFJ or one of the equivalent names for that same angle. All right, let's do 26 as well. We're already here. Am I right? It's already copied down. Let's do it. Let's see, BCG, same angle, and blank are consecutive interior angles. All right. Consecutive interior angles. Is there a way to have a consecutive interior angle from point F's perspective? Well, if point F is the one I'm talking about, the issue is that angle C is not on the interior, so it cannot be a consecutive interior angle from those two intersections. However, if I'm up here, and these are the lines that I'm talking about, my interior is here, so I do have, it is in the interior, and this angle right here would be a consecutive interior angle with it. Consecutive means it's on the same side of the transversal. Notice that they are both on the same side. So we'll call that CGH. There, that's good enough for me. Thanks for watching, internet friends. Bye-bye.